Medians and altitudes of a triangle. Medians of a triangle. A segment whose endpoints are the vertex of the triangle and the midpoint of the opposite sides. What it looks like. So you have a triangle here. This is a midpoint of this left side. This is a midpoint of this left side. This is a midpoint of this this right side. So here. And then the endpoints are the vertex of a triangle. So here's the vertex. Here's the vertex. Here's the vertex. And then it is the midpoint of here to here. So this is called median. So this green line, it connects the midpoint of this side and the opposite vertex, this green. This is called median. This is also the blue line, the vertex and the midpoint of this side. That's median. Vertex here and the middle side, this side. This is called medians. Because median means middle. So it looks like this. So this triangle has 3 medians inside. The medians, the point of a concurrency for the 3 median is called centroid. It's always inside of the triangle. What it looks like. So right here, where they concurrency means where they cross, where they meet and party, right? So from here, this is your median. This is your median. This is your median. So triangle has 3 medians. And where they meet in the middle, right here in the center, that parting where they meet and party, that center, the party place, we call this centroid. This right here. So if you have median, you go from vertex, and here, and then that's right here, this is a centroid. You have here, 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 that's the centroid. So where they meet and party, that's the center, centroid. So this point. So this is a median, this is a median, this is a median because of the marks here. And then this point right here in the middle, where they concur, like intersect, meet, is a centroid. Medians. Concurrency of the medians of a triangle theorem. The medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So can we write this on your paper? So let's write 3 things. So one is for blue, one is for red, one is for green. So let me explain. So everybody write this, vertex to centroid. So this is, let's look at the blue here. So vertex to centroid, let's say it's 2 centimeters, okay? Centroid to side, let's say it's 1 centimeter. So it's 2:1 ratio here. Okay, the ratio. So let's write this. Vertex to centroid is 2. Centroid to side is 1. That's the ratio. Okay. Now let's write this. Look at the red line here. Vertex is here. To centroid is 2. To whole median. So the whole median is from here to all the way down. That's 2 plus 1. Okay. So that's 3. So the vertex to centroid over the whole median is 2:3 ratio. This is what I mean by 2/3 of the distance from each vertex to the midpoint of the opposite side. So the concurrency of the medians of a triangle theorem is the medians of a triangle, this whole thing, intersect at a point that is 2/3 right here. This is 2/3. 2 out of 3 of the distance from each vertex to the midpoint of the opposite side. So right here, where they meet, this is 2, look at this blue line, out of 3. The whole thing is 3. Where they meet is 2 out of 3, right? So this centroid is always 2 out of 3. 2 out of 3 are the whole median. So 2 to 3 ratio. So this red one is what she's talking about. So let's copy this. And the centroid side, so let's look at the green thing. The centroid to the side is 1. Over the whole median is 1:3 ratio. So basically, the longer one is always 2. The shorter one is always 1 on this median. Look at this median. The longer side is always 2. This is the shorter. So this is double of this. Look at the blue one. The longer side is 2:1 ratio. This is always double this. So where they meet is 2/3. They always meet from the vertex, 2/3 of the whole thing. That's where they meet. From here, 2/3 of the whole thing, where they meet. 2/3 of the whole thing, that's where they meet. So centroid is 2/3 of the whole median. So centroid is basically for each vertex, 2/3 of each median equals where they meet, centroid, where they come and intersect and have a party. One more special characteristics of a centroid is this is the balancing point, center of gravity of a triangle. So that's the center where they have a balance, okay? So this is the balancing point, center of gravity of a triangle. So we don't have a index card, but I'm gonna leave some index card in front of the room where the homework is. You know where I always write homework? You're gonna see index cards there. You can grab it and write this down. Otherwise, you can just write on a piece of paper, okay? Or if you have an index card, you can get one or use it. So let's write this. Pause this video and write this centroid on the front, because we did this with some other words. And on the back, you're gonna write formed by medians. Where is it? Always inside. What's special? Breaks each median to 2:1 ratio, with the longer part connected to the vertex. It is the center of gravity, balancing point of a triangle. So can you please write this? And this is vertex to centroid and centroid to side is 2:1 ratio. Vertex to centroid over whole median is 2:3 ratio. Centroid to side over whole median 1:3 ratio. So I just wrote this right here on the index card. So you can go back to this, pause the video, and write this on the index card too. So grab an index card or grab a piece of paper or index card if you have. Index cards, I'm gonna leave it right under where I put the homework with a clip. You can grab it and then write this. So let's look at an example. G is the centroid of a triangle BAC. So everybody please highlight G and highlight BAC, the triangle. And G is 8. Find AE. Let's highlight AE. Everybody highlight AE. And then GA. So if you don't have a highlighter, use a pencil or pen to make it dark and look, see what we can do. So in order to find AE, which is right here, it's super easy. The shortest side is always half of the longer side. So if this is 8, this median, this is 2:1 ratio. The longer is 2 and this is 1. So that's 16. So GA is 16 because it's 1:2 ratio. And then if you want to find the whole thing, 16 plus 8 is 24. You just have to add them. It's 1:3 ratio. Okay? So I'd like to put some challenging question on the test. What if, let's say, everybody copy this number too. If G is in algebraic expression, what if it's not 8, it says 7x plus 3? Then you're going to just do 2 times 7x plus 3 to get this part. Because this will be 2:1 ratio. You can use proportions too. So multiply 7x plus 3 times 2, which is 14x plus 6. That will be GA right here. And then if you want to get the whole thing, you add 7x plus 3, which is right here. This is just a new problem. Plus 14 plus 6. So combine like terms. 7x plus 14x is 21x. 3 plus 6 is 9. So you can actually use the ratio like that. Also, you can use 1:3 ratio. Please copy this part on your paper. So let's say if I have a triangle, what if I have ABC, something like this, and then I give you, okay, so from here to here, you have the centroid here, centroid, and then this is 10x minus 1, okay? What is AF, the whole thing? So you know this point is 2/3 of this, the whole thing, right? So you can use 2:3 ratio. 10x minus 1 over this equals 2:3 ratio. So you can cross multiply and divide. So you do 3 times 10x minus 1, which is 30x minus 3, divided by 2. So 30x divided by 2 is 15x. Negative 3 divided by 2 is negative 3 over 2. So this whole thing in algebra style is 15x minus 3 over 2. You can do other ways to do this. You can double it and add also. It's the same thing. So what is altitudes of a triangle? The perpendicular segments from a vertex to the opposite side or to the line that contains the opposite side. What it looks like. So this is the vertex. You draw a straight line and make 90 degrees. This is an altitude. You have to use vertex. A triangle has 3 vertices. This is a vertex. So you just draw a straight line and do 90 degrees. This is an altitude. If you draw a straight line from this vertex and 90 degrees, that's an altitude. So each of these, if you make 90 degree angle, then these are altitudes. So there are 3 altitudes here. The point of the concurrency for the 3 altitudes are called orthocenter. It can lie inside, on, or outside of the triangle. What it looks like. So if you have an acute triangle, you have median, 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 and 90, 90. So this is, median is now have a special name. If you have a 90 degree, if a median has forms a 90 degree inside, that's altitude, altitude, altitude. You're always gonna have 3 altitudes in an acute triangle. Then this is called orthocenter. It's not centroid, it's orthocenter if you have a 90 degree. Only when you have 90 degrees. Now, if you have a right triangle, you will have from this vertex to this, that makes 90. This is where they're going to meet. That's orthocenter right there. Right triangle has only 1 altitude because if you use this vertex and then go that, it's going to be not 90 here. If you use it, do that, it's going to be 90. Why don't you draw it and look at it? If your right triangle is like this, you can also do that. Right here, you have obtuse triangle. Your orthocenter is right here. So from this vertex, you can go outside actually. Look. Go outside, outside, outside. It will meet outside of the triangle for obtuse. So you can have 3 altitudes like this with the 90 degree. This is the orthocenter. So for obtuse, that's special. You have 3 altitudes. Altitudes has to have 90, has to form 90, and that is orthocenter right here. So please grab another card and write orthocenter on the front of the index card, and then write the following things on the back. On the front, write orthocenter. On the back of your flashcard, you're going to write formed by altitudes. Where is it? Acute, it's inside. Right, it's on it. Obtuse, it's outside. What's special? Nothing. So you can see inside, on it, it's on the triangle. This is outside, always, okay? This is the case always. So let's identify. Look at this triangle. The segment AD is just median. If it bisects CB, that's median. Okay, median means middle. Bisecting median. EG is just connecting 2 points. There's no bisecting here. There's no marking here. So let's just write neither. Look at CF. It makes a 90 degrees. So this is altitude. It's not median. It's altitude. Okay. I want you to pause the video and copy this chart, and I'm going to explain this when I come back. So where can the intercenter and centroid of a triangle be located? Where can the circumcenter and orthocenter of a triangle be located?